What is radiation? Radiation is energy that comes from a source and travels through space and may be able to penetrate various materials. Light, radio, and microwaves are types of radiation able to penetrate various materials but are called non-ionizing as they do not interact with matter and are considered to be safe. Ionizing radiation, however, is considered to be dangerous as it produces charged particles which can interact with matter and DNA on a subatomic level and cause mutation. Atoms with unstable nuclei are considered to be radioactive, and in order to reach stability, these atoms give off or emit the excess energy or mass. The emissions that are given off are called radiation. There are different kinds of radiation, such as electromagnetic or particulate. Gamma radiation and X-ray radiation are examples of electromagnetic radiation, while beta and alpha radiation are examples of particulate radiation. Gamma radiation originates from the nucleus of an atom, while X-rays come from the electronic part of the atom. Nuclear power is the controlled use of nuclear reactions to release energy for work, including propulsion, heat, and the generation of electricity. Nuclear energy is produced when a fissile material such as uranium-235 is concentrated such that nuclear fission takes place in a controlled chain reaction and creates heat, which is used to boil water, produce steam, and drive a steam turbine. The turbine can be used for mechanical work and also to generate electricity. Radioactivity was discovered in 1897 by the French physicist Antoine Becquerel. Atoms are composed of one or more electrons and a nucleus. The nucleus is the central portion of an atom and contains one or more protons and zero or more neutrons. An element is the simplest stable building blocks of materials, consisting of protons, neutrons, and electrons. An isotope can be defined as an atom of an element with the same number of protons but different number of neutrons. We define a radioisotope as any unstable isotope that undergoes nuclear decay. In today's lab, the aim would be to determine the half-life and decay constant by the burette method. The apparatus would be a burette, water, a stopwatch, and a beaker. The procedure entails filling the burette above the zero mark and then setting up the apparatus as shown. The burette top was adjusted to allow quick dripping. The burette was also refilled if needed. The time T was later recorded on the stopwatch at which 5 cm³ interval in volume without stopping the stopwatch. Volume measurements were recorded with its corresponding time value noted on the stopwatch until the volume that remained was below the 10 cm³ mark. We then repeated the procedures without adjusting the top. The graph that was achieved was an exponential curve as shown in the diagram. Radioactive decay is a completely haphazard or random process in which nuclei disintegrate quite independently. Since there is always a very large number of active nuclei in a given amount of radioactive material, we can apply the method of statistics to the process and obtain an expression for the certain fraction of the nuclei originally present that will have decayed on average in a given time interval. From the experiment, it can be concluded that the successive half-lives are constant